This is Astronomy Daily Live, and it is 2 hours UTC. Hey, everybody, you can call me Cosmic, and welcome, welcome, welcome. Come on into the circle of friends who, you know, every single day turn off the TV, forget about the news, and think about astronomical things and space things. Think about the universe. Think about telescopes and eyepieces and stars and planets and supernovae and galaxies, planetary nebulae, open clusters, binary stars, neutron stars. Ah, what else is there? Barred spiral galaxies, elliptical galaxies, orbits, asteroids, comets, moons, volcanoes, rings. Just there's so much, right? There is so much. It's just absolute insanity. Bobby Burgess is in the house. Miss Lady Catherine in the house. Nice to see you. Hearts all around. So hope everybody's doing well. I've it's uh, it today was a holiday in the United States, so they told me to stay home, and so I did. So I did, and yeah, been working on a couple of things. Finally, um, got back working on my software to do the photometric analysis of some data that I took with this scope there and a CCD camera and yeah, there my head just wasn't in it. So I tried to work on that for a couple hours, and my head was just getting foggier and foggier and foggier. So it's like, oh man. So yeah, another sort of a lazy day. Ata is in the house. Nice to see you there in the chat. Glad you could stop by again. So uh, I I've been over at the PDS again, the Planetary Data System, once again today, and wanted to look at some telemetry data and see if there was anything interesting there, and because I mean, what I'm I'm looking at the PDS for sort of two interesting sources. One is for some interesting um, data that can be um, analyzed and examined and all of that. But I'm also looking at the PDS for a source of artwork, of art, and uh, you know telemetry data is sort of um, housekeeping information, right? I mean, it sort of depends on the source, but but uh, um, uh, but sometimes there are some interesting things, and so I went over to the Maven archive once again. I it's sort of an arbitrary choice, sort of what spacecraft I choose. All the data is is there. So I just sort of, follow my nose and don't worry too much about what the source is. Knowing what the source is, at least for me, sort of allows me to put what I'm creating in terms of artwork in some kind of a perspective. And and so what I did this afternoon, I just started working on this maybe a couple hours ago. So it's still sort of uh, um, developing, but I went over to the um, latest data release from MAVEN, and I went into the guidance, navigation, and control um, archive for uh, this data set is for January 1st through the 5th, or day number 1 through 5 of 2018. And there was something like 200 and I'm not gonna, let's see if I can, maybe if I just do that. Yeah. So for those 5 days, there are like 250,000 data records. Um, uh, and in the case of guidance, navigation, and control, there are 12 data columns. And I haven't even bothered to look and see what they even are. Let's see if I can. Let's see if there's any indication. Yeah. Um, I'm looking over on my Linux machine at the XML file um, that describes the data, right? And I'm seeing things like, let's see. Spacecraft attitude, angular rotation rates in X, Y, and Z. I need to tweet. Thank you, Uncle Bill. Uncle Bill always tweets me first, and then I do it. That's not always true, but as I say, I get going in these things, and it's like I forget all the other things. So yeah, let's see. I'm looking at this. Where was I looking at that? Oh, I was looking at it on my browser. Yeah. Um, uh, outer gimbal axis angles, digital tachometers. So yeah, just some data, right? And so what I decided to do this, and this is sort of the artistic license that can be done, is that I wrote a little Perl script to create a script that my plotting program can read. Um, Plotting program is called GNU plot, and so I wrote a little Perl script to take every 3-column combination and treat those as X, Y, and Z coordinates and plot them. Just draw some lines and see what they look like, right? Because I mean, what you're doing there, right, is you're showing the relationships between these parameters. And yeah, it came up with some pretty interesting shapes. Now, I have to warn you, right, that I'm dealing with 12 columns, right? Um, and I'm taking 3 of those columns and plotting them. So every combination of 3 columns out of 12 yields something like let's see how many plots. DRF. Well, let's do it like this. GP. I've got these weird names for these. So this is starting on line 7. So 39. Got my handy dandy calculator here. 39, 65 minus 7. So there's about 1,900 possible unique plots. In fact, exactly 1,979 unique 3 combination plots using 12 columns. So I'm definitely not going to be able to show you all of these, but as I said, I mean, as an artist, what I do is I can't draw, right? At least I can't draw things, but I can tell a computer to do that. So wow, we got a whole new crew in here. Tom is here. Hey there, Tom. Gilles is here. Hey, hey, hey. Nice to see you there. Patrick is here. Cool, cool. So yeah, any kind of conversation that you folks want to have, um, please do, and I'll join in. I've I've got my own agenda, but that can change on a dime, right? So I'm just going to show you some, dare I call it, artwork um, using guidance, navigation, and control um, um, uh, data from the MAVEN spacecraft that is currently orbiting Mars. And it's just some interesting patterns. As I say, these plots show various relationships, right? So let me show you actually. This is the first one that I saw. When I first did a 3D plot, taking 3 columns um, and plotting them, this is what I saw. I saw that. I'm gonna get my live stream going here, like that. There I am. Okay. So I saw that, and I looked at that, and it's like, huh, that's kind of interesting. That's kind of interesting. So then it's like, oh, well, I wonder what other columns look like. And then that, of course, that exploded because um, I could then write a little script to create plots for all the combinations. So yeah, I think let me just run through a few of these, and I would appreciate feedback. I mean, if this is like just absolute garbage crap, tell me. But I think they're moderately interesting? I don't know. So I'm just going to run through these. I don't know. Yeah, I'm just going to run through a few of these things and see if these look moderately interesting. Look sort of the same, right? Because they're using the same, at least one of the axes here is using the same data, right? And I don't know if you can tell or read the file name down here, but it's like 7, 8, 12. Those are the actual columns I used. See, so 7, 8, 12. Now it's going to go to 7, 9, 2. I don't know, 7, 8, 13, 7, 9, 2. I don't know. Are these am I just a little too strange that I sort of find these interesting? Some of these look like weird like antennas, like that one. So what do you think? I haven't even actually plotted all the data here. I've plotted, out of the 250,000 data points, I plotted every fifth one. So I'm actually uh, uh, these things only represent uh, 1/5 of the data, and I can change the line widths, and I can change the colors and all that. But for right now, I was just sort of interested in seeing what I got from these. The other thing that I've done in the case of these plots, and I mean you can't tell this, but I've randomly changed the viewing angles inside a GNU plot. You can do that. Um, yeah, Atta, what these are showing in terms of sort of science value is relationships. Um, so yeah, I don't know. I don't know. Well, it's trying. Yeah, yeah. I don't know if these are interesting or not, but I wanted to share the just to sort of put them out there. I don't know. They are, I mean, I don't think I've ever seen anything necessarily like this, and it is, I mean, I totally agree, Patrick. It does, it sort of, um, yeah, it sort of looks like scribbling, right? But this is actual data. This is telemetry data from a spacecraft. This is what it looks like. I'm just sort of I'm presenting it in a way that I guess you normally wouldn't. So I don't know. This is one of those things that it's like, well, I don't. It's moderately interesting. Yeah, I see weird looking antennas for sure. Yeah. I also, I mean, in something like this, I'm almost seeing like these are like lightning bolts, right? Zzz. It's like a weird Tesla coil or something. That's pretty cool. That's pretty interesting. I don't know. Is that a little too weird? I don't know. I mean, there are 2,000 of these that, that I generated. So, well, really, I think it is all about relationship. That's that's what I mean. Every single scientific plot that you will ever see, right, is a relationship, right? I mean, it can be color versus magnitude, right? And um, what that makes is what's called um, the Hertzsprung-Russell diagram, right? Which is like really important to people, who want to study the evolution of stars. So, I mean, this is the same kind of thing. It's showing relationships. But yeah, I mean, this is 5 days worth of data, right? There are years worth of data here. So, and every single one is going to be unique and different. So I'm just thoroughly entertained by strange things, I guess. So I don't know. Let's. I'm still only on column 8 here. Let's go to let's go down to like column 11. See what else is hidden is hidden away. So that's column 11, 4, and 6. 11, 4, and 7, 11, 4, and 8. Yeah, very abstract. I sort of like the abstract stuff though. And as I said, I mean, what makes it interesting, right, is that this is actual data. This is not sort of just, me scribbling, right? This is actual spacecraft telemetry, guidance, navigation, and control telemetry from a spacecraft that is at Mars right now. These all sort of look almost the same, but so yeah, All right, are you tired of that? All right. Let's one of the things that we haven't done in a while is look at the sun. The sun. So um, there's a spacecraft that's um, going around the Earth in in what's called a sun synchronous orbit. Um, it's pretty much a polar orbit um, that is always on the terminator. So it almost always sees the sun, right? So this is a um, 8-inch telescope, right? So I mean, it's exactly the size of as as the telescope that I have behind me here, right? Um, uh, but in this case, this instrument can not only do imaging, but it can also do spectroscopy. So it can take a spectrum of the exact location that it's looking, and this data is all there for us to grab pretty much whenever we want. See, some of it is so new, right? So here's May 28th at 18 hours 32 um, minutes UTC. That was about 7 hours ago, right? So what we do for a giant EM pulse? I don't know. I haven't heard anything like that. Don't know. Don't know. I don't know if there's any kind of regularity to those kinds of things. Yeah, don't know, Atta. So let's skip down here a little bit so we can actually get some data that's available. Uh, so here's some. Let's see if we can find something moderately interesting, and then I'll sort of get into it a little bit, sort of explain a little bit of what we're looking at here, because otherwise it's sort of hard to see. But I'm looking for something moderately specific. Let's see if we can find it. I'm looking for an image of like the edge of the sun. There's one. It's not a lot of images though, so let's keep going here. See what we can find. I can't find anything too interesting. Yeah, not. Well, let's see. So if we click on that, what we get is that. I don't know if there's going to be anything too interesting there or not. So what we're looking at here is an image of the sun taken at 4 different wavelengths. All right, so these I believe are in angstroms. So 1330 angstroms. Uh, okay, yeah, I'm just reading the chat. 1400 angstroms, 2796 and 2832. So in the ultraviolet, right, for sure. But then what they also have are spectra as well. So these are showing um, carbon lines, oxygen lines, um, silicon lines, and magnesium lines. So let's just see here. That's a pretty short thing. Let's is it this one? I don't know. Let's look at the JavaScript thing. Let's just look at this one. The JavaScript thing will make a little movie here for us. So what you're seeing here, of course, is a section of the sun, and what this telescope does is it sort of see that it's going from left to right. And what that allows, you see this dark line right here? Well, that's an actual physical opening. It's a little slot, it's a little slit in the main mirror, in the 8-inch mirror. And what that does is that allows just that light to go through that slit. And that slit is the entrance pupil to the spectrometer. So what they can do, I'm going to pause this. So what they can do is they can get a spectrum of this region of the sun. And because it's scanning, they can actually get a spectrum of a relatively large portion of the sun, right? Including any of the prominences out here too. They can actually get a spectrum of these things, and see what they're made of, see what their temperatures are, look and see how they're moving. All the kinds of things that spectral data allows. So let's just see if I can play this MP4 file. This would be pretty funny if I can. I don't know. It's trying to do something. Probably going to have to download it. So let's do that. Let me download this MP4 file. Save it in the usual spot here. Yeah, well, Jules is right. If I think if we had a Carrington event today, we would that would be pretty interesting. It would definitely, to say the least, I think it would definitely test the robustness of our at least the electrical grid, if not our communications grid. So yeah, it's and those kinds of things. I mean, it's just really, it's just a matter of time, right? It's just a matter of time. And so yeah, that is going to happen. We're actually really lucky, I guess you can say, that our sun is as calm as it is. But yeah, I mean, right now it's in sort of the slow phase of the solar cycle, and there's actually a larger cycle where this low phase is actually very low. And I think what that um, uh, um, um, indicates is is that as the sun comes out of this low cycle, it actually may be more active. And so, yeah, we're just going to have to um, sort of see. So, yeah, I think I think you guys are exactly right. Yeah, we're and I mean, this is going to happen. Um, sort of inevitable. It's a race, I guess. You know, to see um, if we can toughen ourselves up enough, or if the sun is going to fling a bunch of crap at us and knock us out. So yeah, but it's going to happen. It's just a matter of time. Just a matter of time for sure. All right. So while that's going, we can sort of look at these other ones too. So yeah, I just grabbed a random one here. But the cool thing again, right, is that all this data is readily available. It's in FITS format. So you just have to go and grab it. And I mean, there's a ton of data here. It's just an insane amount. Insane amount. Um, let's let's keep looking here. Most of these, you know, they aren't really looking at the limb. They are looking at, you know, some kind of active area or some kind of um, interesting area on the rest of the sun. Yeah, this is a very active telescope looking at the sun pretty much 24 hours a day and grabbing lots and lots of data. And sometimes, especially stuff on the edges, you know, when you can get a movie of like the prominences and stuff, they're really fantastic, you know, just to watch them. Not seeing anything incredibly interesting here, at least for show and tell, at least. But I think once this movie downloads here, I'll be able to talk a little bit more about the spectra. Because that's where a lot of the useful information is in these spectral features. Let's see. It's kind of an interesting active region here. We should look at one of these at least, right? Let's look at least one of these just to give you an idea of what these look like. Oh, be downloading two things at the same time, so it's going to be a little funky, but these will load fast. Ooh, that's, you see all that white stuff? Yeah, do you know what that is? I've talked about it a couple times, I think, already. Paul the cat. Hey, kitty, kitty. Yeah, I've got a kitty on my desk here. She's um, uh, she's completely twisted and kneading in midair. So, you know, her paws are, you know, going in and out, in and out. So, yeah. Yeah. So that white stuff, I'm not quite sure what these black squares are. That's a little strange. But you can sort of tell that there's some activity on the sun itself. But that white stuff is when the spacecraft moves through the um, South Atlantic anomaly. So, you know, there's just a lot of extra stuff there that it has to move through, and these CCD cameras are sensitive to that. So you get this snow. In fact, one of the projects that I haven't actually worked on in quite a while, but I can actually use this data to map out the shape um, and the intensity of the South Atlantic anomaly, which I have done. So let's take a look at this movie here. Let's see. Downloads, Astro, and I'm going to back this up so we're not running that. Get rid of my lightning. Yeah, I don't know if I don't know if those black boxes are part of the machine just having some trouble, or if it's actually part of the data itself. It can go either way. This thing loves to index. Every single time I come over here, it has to index. I don't understand that. Slowly, it's indexing. All right, let's take a look at this. Good old VLC. Making this poor machine work harder than what it wants to. It'll eventually come up here. There we go. Okay. Okay. So this will just go in a loop here. But yeah, there's all kinds of interesting things going on here. So as you can see above here, right, these are spectral lines that um, this instrument is able to detect. Carbon 2 at 1336 angstroms, oxygen 1 at 1356 angstroms, silicon 4 at 1403 angstroms, and then the magnesium 2 lines that are around 2796. And so what these spectra are showing, remember there's that dark line, you can barely see it here, right? Barely see it on the image itself, right? And so as as this slit scans across the surface of the sun, you're picking up different features on the sun. And as you can see, as the top of the slit moves off of the sun, the spectra seem to sort of drop off, right? Which is kind of cool. But look at all that interesting stuff out there. So, this is looking at the prominence here, right? There's a little bit of a prominence right here, and you're actually seeing that in the spectrum, and it changes over time. It's extremely dynamic, but we're seeing carbon, oxygen, silicon, and magnesium in the atmosphere of the sun. And very dynamic, very dynamic. So I know that this isn't showing up incredibly well over the live stream, but I hope you sort of get an idea about what's going on there. So it's just, this axis, right? The long axis is sort of a spatial axis, right? I mean, it's scanning along this entire area. But the other axis, this way, is actually wavelength, right? And then the brightness of this is just the intensity of that feature. So yeah, very, very cool. Very, very cool. As far as I know, Atta, this is pretty much the latest version of VLC. VLC is pretty awesome. But you can see there's all kinds of interesting structure in here. There's actually the magnesium lines. You can sort of see a dark line right in the middle of these. That's an absorption feature. Don't remember exactly what that is all about, but you can see flashes occasionally, and the the positions of these lines as you move spatially around, you can see that they change a little bit in terms of wavelength. And what you're actually seeing there is redshift or blue shift. You're actually seeing things either moving towards us or moving away. So you can actually measure the velocity of this material just by looking at the spectra here. So that's moderately cool. That's moderately cool. Whoop. Oh, I got rid of my whole. Wow, I got rid of my whole. I don't know how I did that. All right, let me go back to. I'm going to stop sharing for now, and I need to try to. There we go. I need to actually pull up another Chrome because for some reason my Chrome window vanished on me. So let me pull up another Chrome. It's a little strange. I don't know why I did that. Let's go back over to Iris, see if there's anything else interesting over here. Okay, I think, let me try to share again. Is that going to work? Recent observations. Yeah, okay. All right, let's go. I don't know where exactly we were, so I'm just going to skip forward a little bit. So this is back a month ago or so. Let's see if there's anything interesting here. Not going to be able to see a lot of prominences or anything because there really aren't a lot of active regions right now. Probably why we're not seeing too much. It's like a maybe a sunspot. Hard to tell. Let's see. Yeah, so there's sort of a interesting looking sunspot. Let's look at that at 2832 angstroms. So this is just short bull. We've got some pretty rapid scanning there. Sort of zoomed in view of a sunspot region. You can see all the granules, as they call them, these um, convective cells. Hide that. Oh, 652 pictures here, so that'll take a little bit of time to load. But yeah, the cool thing about this is that this is an 8-inch telescope, so it's exactly the same size as my scope. Except for any kind of um, atmospheric distortion, this scope is seeing pretty much the same thing that mine would too. So there, it looks like it's moving like anomaly again. A little bit of noise on there. Moves through the SAA. Halfway done. Once this movie gets running, you'll really see some interesting motions. But over the live stream, it's a little bit hard. Gilles, some have right, just have metabolism. Cats here, they are sisters, right? One skinny, not like, but skinny, slim, and small, and her sister, who's the one actually laying on my desk here. Here, I should show you a picture of this because she's really in a. While this is loading, let me stop sharing that. I will show you. I will pull the camera off the laptop here and show you what I'm seeing here. Hopefully, there isn't any incriminating pieces of material around here anywhere. But here, let me Let me show you what I'm seeing. There she is. Let me zoom out a little bit. she's dreaming. She's actually in a dream state. Let's see if I can. Oh, where is she? There she is. She's actually dreaming. That's really funny. Look at that mouth. Oh, that's hilarious. That's hilarious. Oh, poor kitty. Sorry, I'm really awful with this camera. There she is. At least her face. You can sort of see the rest of her here, right? So she's a big kitty, right? I mean, look at that. She's a big kitty. So, as I said, she's really, really big. Her sister's really, really small. And they eat, I mean, they have access to the same food. They probably eat about exactly the same. So my recommendation is for both of you is if you're healthy, and don't worry too much about your weight. You know, who cares? I mean, if you feel okay, no worries. Yeah, I don't know what she, I don't know, but that open mouth is very, very cute. All right, let's go back to the sun here. I'm going to share this again. She's putting her paws on my keyboard, which is not a good idea. So let's go back over here. Okay, so now you can see that this thing is scanning very rapidly. And you might be able to tell in the live stream that there's a little bit of action up here. It's sort of hard to see, right? But anyway, that's a sunspot region, and they're actually um, looking at the spectra going right across there. So that's pretty cool. That's pretty cool. I don't know if let's see. Yeah, she's a trip. She is definitely a trip. Yeah, they just have the MP4s for these guys. I don't know what these are. Let's look at the spectra again. That might be moderately interesting. Yeah, she's awake now. I bothered her a bit too much. Okay, this is a short one. 30 seconds. Although it's going up in time, it's staying at 30 seconds. There it goes, 20 seconds, 10 seconds, 0. Okay, so it should be there. It's going to index again, isn't it? No, it's not. Okay, so let's look at this with VLC. You get another glimpse at the spectra and the spectra of a sunspot this time. Okay, well, this is really, really short, and it's actually this one is such that it's not actually scanning across the actual sunspot here. So but we are seeing some interesting variations. You see this little when this thing sort of flares up here. You can see it in the spectrum. Kind of cool. See how these lines get wider right there. See, probably happen over here too. Yeah, see how they widen out. That's saying something. Not quite sure what. But anyway, this is again another awesome source of data and uh, you know potentially hours and hours and hours of viewing time. Um, because yeah, there's just so much data there. It's absolutely insane. It's absolutely insane, and um, data like this is only going to be becoming more and more and more over the next few years, uh, and for somebody like me, um, having access to all of this is great. It's also overwhelming, right? Um, so, all right. Well, why do kitties like to lay on keyboards? I don't know. I don't know. Well, I think I'm going to get out of here for now. I think, yeah. I'm being summoned. I'm being summoned. So, yeah, I think I'm going to get out of here for now. That's just a quick tour of at least one small part of the sun, and also looking at some telemetry data from MAVEN. I don't know if it's interesting or not. We'll see. I'm gonna play with it a little bit more. Um, but I think for now, I'm gonna get out of here. So everybody have a great evening, a great day, and yeah, I will see you again in a little less than 23 hours. I will see you on the spin. All right. Take care, everybody. See you later. Bye.